Hello everyone. In Lecture 5, we are going to learn about chemical reaction. In chemistry most of it's involve reaction. It is like cooking, following a recipe in a form of chemical equation. Chemists spend their time to create something new or new product in the chemical reaction. Today we will learn what chemical reaction is and the effects to our human life and environment. The synopsis of this chapter covers chemical reactions, chemical equations, type of reactions, energy in reaction, acid-base reaction, and special topic on the connection of chemistry with health and environment. There are 7 topics will be covered in this chapter, which are 5.1 Introduction, 5.2 Chemical equation, 5.3 Type of reactions, 5.4 Energy in chemical reaction, 5.5 Acid-base reaction, 5.6 Chemistry and health, and lastly 5.7 Chemistry and environment. Chemical reaction occurs everywhere. It takes place around us and even inside us. They are involved in many of the products we use daily. For example, the fuel in car burns with oxygen, O2, to provide energy to make the car move. When we cook food, also involve chemical reaction. In leaf of trees and plants, where water and carbon dioxide, CO2, are converted into carbohydrates. Some reactions are simple, like the combination of hydrogen and oxygen to form water, while some are quite complex, like synthesis of protein molecule from thousands of simpler molecule. However, they can all be written with the chemical equation. Chemists used chemical equation to describe the chemical reaction, like a recipe to prepare food. In reaction involve 2 things. Reactants, the atoms in the reacting substrate. Products, reactants are arranged to give new substances. However, the atoms in the reactants are the same atoms as in the products, which means the matter is conserved, and no matter is lost during reaction. But, how to identify whether the reaction is occurred or not? Because we couldn't see the atoms and molecules. So, we need other way to identify it. Many chemical reactions produce easily detectable changes when they occur. Examples: A color changes. When we expose our shirt to the sunlight, the color fades. This color changes is evidence that the chemical reaction is occurred. A formation of solid. When you evaporate a salt solution, at the end you will found that solid particles. A formation of gas. Example in a gas evolution reaction. Have you ever drink Eno? When you pour Eno in a glass of clear water, you found that a few bubble rise up. The emission of light and the emission or absorption of heat are also evidence for reactions. For example, a natural gas flame produces heat and light. However, all these are not definite evidence. Only chemical analysis showing that the initial substrates have changed to new products conclusively proves that a chemical reaction is occurred. Next, we move to the chemical reactions. We expect there are 2 changes that will be occurred, which are physical and chemical changes. Physical change: the appearance of a substance is altered, not its composition. Example: water. When it becomes a gas, or freeze to a solid, it is still water. Chemical change: the substance changes into a new substance. Example: fermented grapes are grapes that we stored in a container for certain time. They undergo fermentation process and produce ethanol as a byproduct. Second topic is on chemical equations. Chemical reactions are represented by chemical equations. They tell us the material or reactant we need and the product that will form in the reaction. In an equation, reactants are written on the left and products are written on the right. We always use symbols to represent certain meaning. Examples: we use plus sign to indicate 2 or more formula in one side, such as sodium, Na, plus chloride, Cl. Delta sign indicates heat was used to start the reaction. Physical state of the substances as solid, S, liquid, L, gas, G, and aqueous phase, AQ. The reaction must be written in a balanced equation. It shows same number of atoms for each element on both sides. Consider this example, the chemical equation to represent a burning of carbon. Is the equation balanced? The answer is yes, because the equation consists of 1 carbon and 2 oxygen on both sides. Now, let's try this sample question. Hydrogen and nitrogen react to form ammonia, NH3. A. What are the coefficients in the equation? Answer. There are 3 coefficients. 3 for H2, 1 for N2, and 2 for NH3. B. How many atoms of each element are in the reactants and products of the equation? Answer. Reactants, 6 hydrogen and 2 nitrogen atoms. Product, also 6 hydrogen and 2 nitrogen atoms. Okay, now we know that every chemical equation must be balanced. Here are the steps on how to balance the equation. Number 1, write an equation, using the correct formulas. As the first step, we need to write the equation using the correct formula for both sides. In the equation, there is CH4 plus O2, to form CO2 plus H2O. Number 2. Determine if the equation is balanced. In second step, we need to compare the number of atoms on both sides. From the equation, there are 1 C, 4 H, and 2 O, on the left side. While, on the right side, there are 1 C, 2 H, and 3 O. This means, this equation has balanced number of C, but not balanced number of H and O. From the previous equation, we noticed that it was not balanced. Therefore, in the third step, we need to balance the equation one element at one time. Balance the equation by placing coefficient in front of the substance. Here, we put 2 in front of H2O. In the final step, check to see if the equation is balanced. Recheck the number of atoms for O, H and C in both sides must be same. Now, we move to the next topic on types of reactions. There are great number of reactions occur in nature, in biological system and in the lab. All these reactions are classified into 4 general patterns. First is combination reaction. This means the reaction involves 2 or more elements or compounds bond to form one product. In the first example, it shows the reaction of sulfur plus oxygen to form sulfur dioxide. In the second example, there is magnesium oxide plus carbon dioxide to form magnesium carbonate. The second reaction is decomposition reactions. This reaction involves a single reactant splits into 2 or more products. In the first example, it shows the reaction of calcium carbonate splits into calcium oxide and carbon dioxide. In the second reaction, mercuric oxide splits into mercury and oxygen. Next is replacement reaction. In this reaction, elements in compounds are replaced by other elements. There are 2 types of this reaction, single and double replacement. In single replacement reaction, elements in compounds are replaced by other elements, and an uncombined element takes the place of an element in a compound. Here is the example of single replacement reaction, A plus BC, to form AC and B. In this reaction, A replaces B to form new compound, AC, as product. In double replacement reaction, the positive ions in the reacting compounds switch places. As example, here is the reaction of AB plus CD, forms AD, and BC. Combustion reaction. Oxygen is used to produce an oxide, water, and heat. Combustion of methane in oxygen produces heat. The heat produced is used to cook our food. This reaction also happened in our own body to metabolize food. So, the heat produced can be used to do any activity we need. We breathe oxygen, it will react or burn with glucose to produce carbon dioxide, water, and energy. Next, we move to the energy in chemical reaction. Almost every chemical reaction involves a loss or gain of energy. To discuss this, we referred reactants and products as system. And everything else in contact with the system is called surrounding. The energy was measured by using heat of reaction, or sometimes called as enthalpy change, symbolized by delta H. Enthalpy change, delta H, is the name given to the amount of heat that flows into, absorbed, or out of, given off, a system at constant pressure. When the heat flows into the system, the sign is positive. When the heat flows out of the system, the sign is negative. The enthalpy change can be calculated based on this equation. Delta H equals to enthalpy of products, minus enthalpy of reactants. When the product has greater enthalpy than the reactant, then delta H will be positive. That means the reaction is endothermic. When the product has lower enthalpy than the reactant, then delta H will be negative. That means the reaction is exothermic. As introduced in the previous slide, there are two types of reaction when involved energy, which are endothermic and exothermic. Now, let's see what is endothermic first. Occurred when the energy of products is higher than the reactants. So, the reaction requires energy. How is this reaction happened? By absorbing heat from the surrounding flows into the system. Delta H value has a positive sign. For example, splitting of CO2 to its components. The system needs energy, so delta H is positive value. Exothermic occurs when energy of reactants is greater than the products. So, it has to give off the energy to the system. In a form of heat, the heat from the surrounding flows out from the system. Delta H value has a negative sign. For example, in the thermite reaction, reaction of aluminium and iron 3 oxide produces a great amount of heat. Heat is given off, so the value must be negative. This reaction is used for cutting or welding railroad track. Most of reaction occurs in solution. One of them is acid-base reaction. Acid characterized by its sour taste, and tendency to form H+ ions in solution. While base characterized by its bitter taste, and tendency to form hydroxide ions in solution. Acids and bases are also found in many everyday substances. Foods such as lemons, limes, and vinegar contain acids. While soap, coffee, and milk of magnesia, all contain bases. When acids and bases are mixed, the hydrogen ion from acid combines with hydroxide ion from base to form water. For example, consider reaction between HCl and NaOH as shown here. It is also called neutralization reaction, generally forms water and ionic compound called salts. Now, as usual, we learn on the connection between what we have learned today with our health and environment. Here, you will learn on how acid and base concept helps us in neutralizing excess stomach acid. Our stomach normally contains acids that are involved in food digestion. Certain food and stress can increase the level of acidity to uncomfortable levels, causing acid stomach or heartburn. Antacids are usually used as medicine to neutralize stomach acid. Antacids employ different bases as neutralizing agents. For example, milk of magnesia contains magnesium hydroxide. Tums contains calcium carbonate. Mylanta contains aluminium hydroxide. They all have the same effect of neutralizing stomach acid and relieving heartburn. Next, we see the connection with our environment, concerning on smog and health. There are two types of smog: photochemical smog, and industrial smog or London smog. Photochemical smog requires sunlight to initiate reactions that produce pollutant, such as nitrogen oxide and trioxygen or ozone. It is most prevalent in the cities, where people depends on car for transportation. For example, nitrogen oxide, NO, emissions from car exhausts, will react with oxygen gas in the air, to produce nitrogen dioxide, NO2. Nitrogen dioxide is a reddish-brown gas, that is irritating to the eyes, and damaging to the respiratory tract. When it is exposed to the sunlight, it is converted to oxygen atom. Oxygen atoms are very reactive, and they combined with oxygen molecules to form ozone. In the upper atmosphere, the stratosphere, ozone is good because it protects us from harmful ultraviolet, but at lower atmosphere, it will irritate the eyes and respiratory tract, and can cause coughing, decreased lung function, and fatigue. It also can damage trees and crops. Next is industrial or London smog. It is prevalent in the areas where coal with high sulfur content is burned to produce electricity. During combustion, sulfur is converted to sulfur dioxide. Sulfur dioxide is damaging to plants, suppresses growth, corrosive to metals, and damaging to human. It also can cause respiratory difficulties. When sulfur dioxide reacts with more oxygen, it will form sulfur trioxide. Sulfur trioxide combines with water in the air to form sulfuric acid, which makes the rain becomes acidic. Sulfuric acid can increase the acidity in rivers and lake, causes the acidity of water, and reducing the ability of animals and plants to survive. For recapitulation, students should be able to understand what is chemical reaction, chemical equation, balancing a chemical equation, types of reactions, and energy in chemical reaction. We have reached towards the end of our lecture for today. Hope you enjoy this lecture, and wish to see you again next week. Bye.